Okay, so good morning, everyone. Still very less number of students are there in this lecture. Actually, you are not physically attending the lecture, so no need to go for international conference hall. So we can join here in the lecture, but still, okay, not an issue. We'll start with our lecture. So today I'm going to cover the Google Cloud platform. I will share my screen. Hope my voice is audible to you. Okay, so let us start with the Google Cloud platform. So Google Cloud platform, our Google Cloud platform is having, means it is the branch of cloud computing as we know. As we know, cloud computing is defined as these services offered through remote server on the internet. So these services might include the database storage applications, then compute power and other IT resources over the pay per use or pay as you go kind of a pricing approach. So the remote server allows users to save, modify or process the data on the internet or the cloud based platform instead of storing it on the local server or their devices. So here Google Cloud. So what is Google Cloud? So Google Cloud Platform, which is also known as a GCP, which is the suite of cloud computing services provided by Google. So it is public cloud computing platform. Public cloud computing platform. Already we are aware of what is the public, what is private and all. So this is giving public cloud computing platform consisting of a variety of services like compute, storage, networking, application development, big data, and more, which run on the same cloud infrastructure that Google uses for its end user products, such as Google Search, Photos, Gmail, YouTube, etc. So the services of this Google Cloud platform can be accessed by software developers, cloud administrators, and IT professionals over the internet or through the dedicated network connection. So provided here, you should have a good internet connection. Then why Google Cloud Platform? Why to go for Google Cloud Platform? As we know, Google Cloud Platform is known as one of the leading cloud providers in information technology field. The services and the features can be easily accessed and used by the software developers and users with little technical knowledge. So Google has been on top amongst its competitors, offering the highly scalable and most reliable platform for building, testing, and deploying the applications in the real-time environments. So apart from this, this GCP was announced as a leading cloud platform in IaaS, Infrastructure as a Service Magic Quadrant, in the year of 2018. So Gartner is one of the leading research and advisory company. Gartner organized a campaign where Google Cloud Platform was compared with other cloud providers, and here GCP was selected as one of the top 3 providers in the market. So most of the companies use the data center because of the availability of the cost forecasting, hardware certainty, and advanced control. However, they lack the necessary features to run and maintain the resources in the data center. So here GCP, on the other hand, on the other side, is a fully featured cloud platform which includes the capacity, that is sufficient resources for easy scaling whenever required. Also, effective management of those resources for optimum performance. Then coming to the security. So multi-level security options to protect the resources such as assets, network, and OS components. Then network infrastructure. So number of physical, logistical, and human resources related components such as wiring, routers, switches, firewalls, then load balancers, etc. can be added in the network. Then support. So skilled professionals for installation and maintenance and support are provided by Google over here. Then bandwidth. So suitable amount of bandwidth for peak load is given to you. Then facilities. So other infrastructure components including physical equipments and power resources are provided there by GCP. So therefore, Google Cloud Platform is viable option for business, especially when the business require an extensive catalog of services with global recognition. So some of the benefits of Google Cloud platforms are given over here. So the first is best pricing. So Google enables users to get Google Cloud hosting at the cheapest rate. The hosting plans are not only cheaper than other hosting platforms, but also they offer better features than that of the others. Also, GCP provides a pay as you go option to the users where the users can pay separately only for the services and the resources they want to use. Then work from anywhere. So once the account is configured on GCP, it can be accessed from anywhere. That means that the user can use GCP across different devices from different places. It is possible because Google provides web-based applications that allow users to have complete access to GCP. Then private network. Google has its own network that enables users to have more control over GCP functions. Due to this, users achieve smooth performance and increased efficiency over the network. Then it is scalable. So users are getting more scalable platform over the private network. Because Google uses fiber optic cables to extend its network range, it is likely to have more scalability. Google is always working to scale its network because there can be any amount of traffic at any time. Then security. So there is high number of security professionals working at Google. So they always keep trying to secure the network and protect the data stored on the servers. Additionally, Google uses an algorithm that encrypts all the data on the cloud platform. So this gives assurance to the users that their data is completely safe and secure from unauthorized access or unauthorized sources. And redundant backup, that is Google always keeps backup of the user's data with built-in redundant backup integration. So in case a user has lost the stored data, it is not a big problem. Google always has a copy of users' data unless the data is deleted forcefully. So this adds data integrity, reliability, durability with Google Cloud Platform. Then some of the key features of Google Cloud Platform, which are given over here with the diagram. So in that, the first is the on-demand services. So automated environment with web-based tools is like on-demand service. So therefore, no human intervention is required to access the resources. Then broad network access, that is the resources and the information can be accessed from anywhere. Then resource pooling, is there. That means on-demand availability of shared pool of computing resources to the users. Then rapid elasticity, so the availability of more resources wherever required. And measured services, that means easy to pay feature, which enables the users to pay only for the consumed services, the services which are used. Then so here the Google Cloud Platform services are given in this diagram. So Google provides a considerable number of services with several unique features. That is the reason why Google Cloud Platform is continually expanding across the globe. Some of the significant services of this GCP are given over here. So you can see in the diagram, that is the compute service, the management tools, cloud AI, IoT, Internet of Things, security and identity management, then big data, storage services, and networking. These are the services provided by the Google Cloud Platform. So we'll see each one of them one by one. First of all, the compute services. So GCP offers a scalable range of computing services such as Google App Engine. First is Google App Engine. So it is a cloud computing platform that follows the concept of platform as a service to deploy PHP, Java, and other software. Then it is also used to develop and deploy web-based software in Google managed data centers. The most significant advantage of Google App Engine is its automatic scaling capability. This means that the App Engine automatically allocates more resources for the application when there is an increase in the requests. Then is Compute Engine. So it is a cloud computing platform that follows the concept of infrastructure as a service to run Windows and Linux based virtual machines. So it is essential component of GCP. It is designed on the same infrastructure used by Google search engine, YouTube, and other Google services. Then Kubernetes engine. So this computing service is responsible for offering a platform for automatic deployment, scaling, and other operations of application containers across the clusters of hosts. The engine supports several containers tools like Docker, etc. Then the networking services. So GCP includes the following networking services, in which the first is VPC. VPC stands for Virtual Private Network. The primary function of VPC is to offer a private network with routing, then IP allocation, and network firewall policies. So this will help to create a secure environment for the application deployments. Next is cloud load balancing. So as the name states, the cloud balancing is used to distribute the workload across different computing resources to balance the entire system performance. This also results in cost reduction. The process also helps in minimizing the availability and maximizing the capability of the resources. Then content delivery network, that is CDN. It is geographically distributed network of proxy servers and their data centers. The primary aim of using this CDN, content delivery network, is to provide maximum performance to the users. Additionally, it also helps in delivering high availability of resources by equally distributing the related services to the end users. Then coming to the next, that is the storage services. So GCP has the storage services, like first is the Google Cloud Storage. So it is an online data storage web service that Google provides to its users to store and access the data from anywhere. So the service also includes a wide range of features like maximum performance, scalability, security, and sharing, data sharing. Then Cloud SQL. So it is the web service that enables the users to create, manage, and use relational databases stored on the Google Cloud servers. So the service itself maintains the and protects the databases, which helps the users to focus on their applications and other operations. Then Cloud Bigtable. So it is also known for its fast performance and highly manageable feature. It is highly scalable NoSQL database service that allows collecting and retaining data from as low as 1 terabyte to hundreds of petabytes. Then big data. So GCP provides a variety of services related to big data, and that they are like BigQuery. So it is a fully managed data analysis service provided by Google. The primary aim of Google BigQuery service is to help the business to analyze the big data. It offers a highly scalable data management option. This means BigQuery allows the users to perform ad hoc queries and share the data insights across the web. Then Google Cloud Data Store. So Google Cloud Data Store is a kind of a data store service that is fully managed, schema-less and non-relational. This service enables the business to perform automatic transactions and a rich set of queries. The main advantage of Google Cloud Data Store is the capability of automatic scaling. This means that the service can itself scale up and down depending on the requirement of the resources. and then Google Cloud Data Pro. It is a very fast and easy to use big data service which is offered by Google. It mainly helps in managing Hadoop, Spark services for distributed data processing. The service allows the users to create Hadoop or Spark clusters sized according to the overall workload and can be accessed whenever users want them. Then security and identity management. So this Google Cloud Platform includes the services related to security and identity management, which are given here, and they are Cloud Data Loss Prevention API. So it is mainly designed to manage the sensitive data. It helps the users in managing the sensitive data elements like credit card details, then debit card details, passport number, etc. So it offers fast and scalable classification of the sensitive data. Then Cloud IAM, that is, it stands for Cloud Identity and Access Management. So it is a framework that contains the rules and policies and validates the authentication of the users for accessing the technology resources. That is why it is also known as the identity management, IDM. Then next is the management tools. So GCP includes the services related to management tools, and they are, the first is the Google Stack Driver. So Google Stack Driver service is primarily responsible for displaying the overall performance and diagnostic information. This may include insights of data monitoring, then tracing, logging, error reporting, etc. The service also prompts an alert notification to the public cloud users. Then Google Cloud Console app. So it is a native mobile application powered by Google. The primary aim of this particular service is to enable the users to manage the core features of Google Cloud services directly from their mobile devices, anytime, anywhere. So the primary function of this service are alerting, monitoring, performing the critical actions on the resources. Next is the Cloud AI. So when it comes to Cloud AI, GCP offers the services like Cloud Machine Learning Engine. So it is another fully managed service that allows the users to create machine learning models. The service is mainly used for those machine learning models which are based on mainstream framework. Then Cloud AutoML. So it is the type of service that is based on the machine learning. It helps users to enter their data sets and gain access to quality trained pre-designed ML models. The service works by following the Google's transfer learning and neural networks search method. Then comes the IoT, Internet of Things. So GCP contains the following IoTs, that is Cloud IoT Core. It is one of the fully managed core services. It allows the users to connect, control, and ingest data from various devices that are securely connected to the internet. This allows other Google Cloud services to analyze, process, collect, and visualize the IoT data in real time. Cloud IoT Edge. So this edge computing services brings memory and other computing power resources near to the location where it is been required. So these are the services provided by Google Cloud Platform. Then we'll come to the advantages of Google Cloud. But after watching this particular video,
in this first section of the course, we're going to focus on Google Cloud compute resources. Now, by compute, we mean virtual machines that can run workloads in the cloud at scale. If you've ever worked with Amazon, you may know EC2, their VM service, or DigitalOcean. Their concept is droplets. If you're familiar with either of these, then you already know a little bit about cloud compute. So with Google Cloud, you have three main approaches to compute: App Engine, Compute Engine, and Kubernetes Engine. We will explain how each of these work in the next lesson, and then we'll give some advice to help you know which is best for different scenarios. And then after that, we'll follow up with two shorter lessons digging into price estimation and planning, and then the virtual machine types. And then the section will end with a video demo of how to actually use all these things. So if you're ready, let's get this party started. Cloud compute is one of Google's core offerings for businesses looking to run their apps in the cloud. It's your foundation, the hardware and CPU cycles needed to actually run your software. Now, under the compute umbrella are a few different specific services and configuration options and products. For our purposes, though, we are going to focus on three main offerings: Compute Engine, App Engine, and Kubernetes Engine. And we'll briefly mention Cloud Functions and Cloud Run. I'll start by giving you a quick high-level distinction between these three main offerings. So Compute Engine is for deploying virtual machines or VMs, much like Amazon EC2. App Engine is a serverless compute product for running code without thinking about VMs. And then Kubernetes Engine is for, you guessed it, running Kubernetes workloads for customers that need container orchestration. So let's dig in a bit more on each service, starting with Compute Engine. As I've said, it is analogous to Amazon's EC2, but let's get a little more specific for folks who may not know AWS. Compute Engine is for deploying virtual machines. You can create a variety of virtual machine types with different amounts of CPU, storage, memory, network bandwidth. You can create VMs in different physical regions, as Google Cloud has data centers all around the world. And then regions have names denoting their location, like US West 1. Each region can have multiple zones, like A and B. So a full location name for a compute resource for a VM could be something like US 1 C, which denotes both the region and the code. So a region is usually a part of a country, like US West or US East. Now, Compute Engine offers a variety of predefined machine types with different operating systems and configurations to match different workloads. There's also the possibility of creating custom machine types if needed, if you need a specific hardware, CPU, memory setup. Billing for these virtual machines is done by usage per second, so you only pay for exactly what you use. And there are also discounts for sustained usage and sort of commitment-based, committed pay up front, sort of commitment-based, long-running jobs. And the lesson after this will cover machine types in more detail. And that lesson will also cover pricing in more depth. Now, let's switch over and talk a little bit about App Engine. App Engine is similar to Amazon's Fargate service. App Engine is designed to let you deploy software without managing individual servers. Instead, you pick an environment and a runtime. Runtimes are language-specific, minimal container configurations. They're runtimes for things like Python 2.7, Python 3, Java, PHP, Node, Ruby, Go. The App Engine environment is the underlying hardware. And when it comes to picking an environment, there are two types of environments you can choose. There's the standard environment and there's the flexible environment. So the App Engine standard environment only supports very specific language runtimes. You can't modify the environment after the fact. You can choose an instance class, which will allocate a certain range of CPU and memory and auto-scaling ability. However, you can't SSH into the instances. It's more fixed. In essence, you can think of the standard environment like a sandbox. It spins up quickly, and it can auto-scale pretty effectively, but the main trade-off is limited ability to alter the environment over time. And then, by contrast, there is the flexible App Engine environment. Now, this does let you modify the runtime via Docker files. So if you know Docker files, you know they're pretty flexible. You can do a lot there. You can set up SSH access. You can run pretty much any programming language. You can access other Google Cloud resources and Compute Engine instances within the network. So in short, the flexible environment does less for you, but it gives you more control. And then the third main Google Cloud compute service is GKE, Google Kubernetes Engine. If you're already running or planning to run a Kubernetes application, GKE is by far one of the best ways to do it, as Kubernetes was actually originally designed by Google. So it's a first-class integration. The GKE platform gives you a very powerful API for managing a Kubernetes cluster. You can do this in the console or via CLI tools. You can quickly get information about the cluster, change config, scale pods, alter the access controls, do all kinds of administrative tasks. Kubernetes in general is known for being one of the most powerful container orchestration frameworks available, but it is also known for being fairly complex, tough to debug. GKE removes much of this pain. With GKE, you do almost everything in the console with a mouse. You get fantastic documentation, you get tutorials, you get quick start guides, and you get very good instrumentation and logging. GKE runs on top of Compute Engine. It's using VM instances as GKE nodes. Now, node is the Kubernetes term for a single compute resource. It's very easy to get GKE to intermingle with Compute Engine resources if necessary. If part of your application is in Kubernetes and part of it isn't, if they're all within Google Cloud, it's not a problem to get them to work together. Now, actually, teaching Kubernetes itself is out of scope for this course, but we will spend a little time covering how to create a cluster in the demo. We'll touch on it briefly. Now, finally, I want to mention two other lightweight GCP compute options that are available for specialized use cases. And these are GCP Cloud Functions and GCP Cloud Run. Cloud Functions are analogous to Amazon's Lambda service. They let you define single-purpose standalone functions that respond to specific events. Now, this is, again, a serverless compute option, and it can work well for circumstances where all you want to do is run some specific function in response to an event that it's watching. So, kind of a targeted use case there. Now, Cloud Run is also a serverless option like Cloud Functions, but the difference here is that instead of running just code, you create containers. Now with Cloud Run, you invoke stateless containers using HTTP requests, or you can have them be generated in response to specifically monitored events. Now this is a very simple way of creating container-based workloads with all considerations of hardware abstracted away. You don't think about even an environment like with App Engine. Now, as of the creation of this course, Cloud Run is still in beta, so we're not going to spend a lot of time on it, but it is definitely worth checking out. So, Compute Engine, App Engine, Kubernetes Engine, your three main purposes. How do I know which to select when working on a Google Cloud application. It's probably easiest to start by thinking about GKE. If you're already using Kubernetes locally or with another cloud provider, then I highly recommend migrating to GKE. Creating a cluster and provisioning needed storage and compute resources takes seconds, and you should be able to reuse much of your existing configuration. Compute Engine and App Engine are great options for everyone outside of the Kubernetes ecosystem. When it comes to these two services, the real question is, how much control do you need? Maybe you like to have root access to your machines by default, or maybe you're migrating from EC2, or maybe you have an unusual environment not easily supported by App Engine. In the base case, I would recommend starting with Google Compute Engine. App Engine is generally a better choice for an earlier stage project, particularly if you can use the standard environment with its various language runtimes. The App Engine flexible environment is more of a niche solution for scenarios where, for whatever reason, you don't want to use Compute Engine, but you don't get enough control from the standard environment. So that's it at a pretty high level. You now know enough about GCP compute offerings to be dangerous. You can differentiate GKE, Compute Engine, App Engine, and you should know a little bit about Cloud Run and Cloud Functions. You should be able to pick what is best for a given project. Very cool stuff. So in the next lesson, we'll take a deeper dive in VM instance types. We'll learn about cost and hardware optimization as we tour Compute Engine's menu of options. See you there.
So much of the primary details related to Google Cloud platform are covered till now. So we will stop over here. In the next lecture, we will see the advantages of Google Cloud platform, and then the difference between all the three platforms we have seen, that is AWS, then this Google Cloud platform. And whatever we have seen in the last lecture, that is Microsoft Azure. Okay, so the difference between all these three we will see in the next lecture, and also some of the details related to the remaining details related to Google Cloud and the demonstration part we will see in our next lecture. Today is a Tuesday, so on Thursday we are having that lecture. So now Shruti is so eager, I think. Now you can put your attendance in the chat window and leave, take your lunch break. Thank you very much. Who is Naneshwar G? You have not updated your roll number with division and roll number like that. Naneshwar G. Pratiksha Mali, Tajmin Bhagwan, put your attendance and leave.